Okay, so I want to look at the other problem this week, which is counseling. So in this problem, you have a number of clubs, you have a number of people, and you have a number of political party. And we're going to represent each club as a node in a graph. So is every person, and so is every party. Okay. Now each club can have multiple members, so we're going to draw an edge with capacity 1 from each club to the people that belongs to the club. Each person only belongs to one party, but there might be some parties that have multiple people. And again, we're going to draw an edge from each person to its party with the capacity 1. Okay. Now we're going to have source and sink. And the way it works, we're going to have from each source to each club a capacity 1. You can think of this as kind of giving each club a ticket or ballot that they can use to fill a name. Then one of these edges will take that ticket to a certain person. Okay, so the club is going to give to its nominee a ticket, and these people here are going to collect them, but because of this capacity here, each person can only take one ticket. So in other words, each person cannot represent more than one party. And then there's a rule that says each party cannot have half or more of the number of people. So we have to put something in here, put a capacity in here on all the edges to the sink to make sure that each party cannot have half or more. Okay, half of what? So I'll erase a few things here, just clean things up so I can. So the number of people on the council would be the number of clubs, okay? Because each club must give one nominee. So number of clubs is the size of the council. We want to make sure that the number of people in each party is not half or more. So what is half? Well, let's try some example, because when you talk about half, you have to worry about rounding up or rounding down and divide by 2. So n, if the number of clubs is 11, the largest you can have is 5, because 5 is less than half. 6 is bigger than half, so we can't do that. If the number of clubs is 10, then 4 is the largest you can have, because 5 is actually half. And if you look at this carefully, if you think about this and try for example, you see that the number of clubs minus 1 divided by 2, where the division is integer division, rounds down, is what you put into this location. Okay, so you put number of clubs minus 1 divided by 2. If you run maximum flow, okay, on this graph, the flow should be exactly the number of clubs. If it is not, and it's smaller, it means that not all clubs can nominate somebody, so it's impossible, right? What if it's possible? Well, you still have to figure out who is actually nominated by each club. So what you're going to do is you're going to look at these edges here. These are the edges that shows you which club nominates which person, and figure out where the flow actually is in these edges, okay? Because there are lots of edges and not the maximum flow may not use all of them. So how do you know? If you look at these edges, if you look into my network flow code, and I'm assuming that you use networkflow.cc, if you wrote your own, then I guess you're on your own. So if you look at networkflow.cc, inside the edge structure, there are 2 things that you want to look at. There's a field called flow. It's an integer that says how much flow is being sent through this in the maximum flow. Also, there's something called isReal. It's a flag that says whether there's an edge in the original graph or if it's some kind of backward edge. that what's needed during the algorithm. So what you have to do is you look at this set of edges again, right? You want to know which edge has its zero is equals to true and flow is bigger than zero. Okay, if that edge is, let's say, this one, that means that this club nominated to this person. So what you have to do is you have to look at all the different edges that connects clubs to people and see which edge satisfy this property. Okay, and that will tell you who is nominated by what club. Now, of course, with network flow or with any of these graph problems, you have to figure out how you're going to label these nodes, because ultimately you're going to have a numerical index for all of these, right? So you have to figure out how many clubs you have, how many people you have, how many party you have the source and the sink. There are many ways you can do this, as long as you're clear in your head or in your program which one is which, that's fine. But if you need some help, maybe you say source is 0, sink is 1, and then maybe clubs are 2 to whatever number of clubs you have. So maybe something like this. Okay, so if you have 2 clubs, then it'll be 2 to 3. And then number of people would be basically sort of clubs plus 2 all the way to clubs plus 1 plus number of people, right, and so on. And you can work it out. I mean, this is not the only scheme that you can use, but this is one way. So you set up the graph, you build it, you run network flow. If it's possible, then you go and look at all the edges and see which one has the edge structure being its real field is true and the flow is bigger than 0. And then you print them up. And that's it.